Hi there, this episode is an audio rip of a YouTube video. If there are any references to the screen or to the video itself, then be sure to go over to YouTube and actually check out the video, which will be the same title as this podcast. Thanks. Okay, so let's now start actually looking at the outcomes on the 2396. Remember how I did it with the 2391 videos? We're just going to look at the criteria of each outcome and kind of break them down to see what the aim of the learning is on this course. So in this video we're going to cover outcome 1, which is very, very small. We're just going to start covering outcome 2 and we'll finish outcome 2 off in a video later on. Okay. So the first outcome is to understand the relationship with statutory and non-statutory requirements relating to electrical design, construction management and verification. On the assignment, it's one question, and if you've done regulations training or inspection testing training, this shouldn't be any further training needed, really. And to be honest, with the design course, you don't really need much new training, new information. What you need to do really is expand on what you've done before with with inspection testing and with the regulations. Here, we should know this. But if you don't, then you kind of just need to step back and look at what you've studied before, because we have statutory and non-statutory. We know the guidance and the regulations are non-statutory. We know that electricity work regulations is statutory. Obviously, with the design, we also need to think about the electrical safety continuity regulations. We need to think about the construction design and management regulations. So you have to think beyond electricity a little bit, more about the actual design and the actual construction aspect as well. But this shouldn't be too much of a problem. That is outcome 1. Now outcome 2, it's bigger, quite a bit bigger. So understand the electrical installations design, construction and commissioning process, and it's there as well in the written, so it's approached in both assessments. The first part is outcome: identify the information required to form a design spec. I don't know how you were trained on the 17th edition, but the way I train it to anyone who's on a course with me is to think about the design process when you go through the wine regulations. When you actually do the regulations course and you think about the layout of the regulations, you've got part 1, which is scope, object and fundamental principles, which tells you if the book is relevant and what its coverage is. Part 2 is definitions, and then from that point it's a design process. So part 3 is assessment of general characteristics, supply characteristics, division of installation, compatibility, maintainability. That's all there. Part 4, protection for safety. You can see it's here. Electric shock, thermal effects, overcurrent, voltage disturbance. And then part 5, selection and direction of equipment, isolation and switching. So if you've studied the wine regulations and you've got that on board, this isn't really anything new. But we need to kind of just go back and think about it more. So from the assessment general characteristics perspective, we've got to consider the purpose, supplies and structure. Okay. Kind of obvious, the intent, what the client's requirements are, what the existing supplies are. With the existing supplies, we have number of type of live conductors, voltage, frequency, external earth full loop impedance, prospective fault current, polarity. Yeah, you get the idea. External influences, we're going to cover these in more depth in a little bit. Compatibility, maintainability, recognized safety services and continuity of service. If you've done a regs course, that should be fairly simple. Okay. Protection against electric shock. We have to achieve basic protection and fault protection. There are 4 common protective measures: ADS, self and PALV, double insulation, and electrical separation, I believe. So, ADS is going to be the common use. But we've got to make sure that we design the system, and every part of the system that we install, we're always aware of what the priority protective measure is, and what the requirements of those protective measures are, and that we achieve that. And in your design process that you're reporting, it's always good to say to yourself, the protective measure that I'm using here is ADS or whatever it is, and make sure you're then selecting equipment and types of wiring system that are going to accommodate that protective measure. We've also got to consider the thermal effects. So we have RCDs for fire protection, 300 milliamp at the source if need be. We have obviously coming through toward the 18th edition the measure of the arc fault, the disconnection device, a detection device. More importantly, if the project or if there's any scenario that describes the location of high significance, such as a museum, an airport, or something like that, or public significance, then there's a much larger need to have a fire propagating installation with MI and stuff. Have a little look at chapter 42 to just pick up on that. But at the design purpose, we've got to consider this need. Same with overcurrent. We have overcurrent, we have voltage disturbances and switching. So overcurrent, you have to consider protection against overload current, protection against overcurrent from a fault. You have to consider voltage disturbances, so we've got like SPDs and things like that if they're needed, and just simple isolating and switching, making sure that our methods of switching, our methods of isolation are correctly selected and suitable. Now, describing the process for designing. Now, there's a difference here. Some questions will say explain, some questions will say describe, and you need to make sure that you understand the angle that you're going into the question with. So here we're going to describe the process for designing a final circuit. So that's quite in depth. Okay. So, describing the methods of doing the assessment of general characteristics. Maybe you'll inquire the supply characteristics. This determination of design current. You'll have to describe your method to do that. We're going to see that now, actually. So we have the method of designing. The method of determining the design current. Again, cable calculations. You're going to have to pick them up. IB is P over V, power over voltage. In all scenarios, you'll be told what the power level is of the equipment you're supplying. Alternatively, you may have to use the diversity in demand, if it's like socket outlets or whatever, to consider what power to use. But most often not in the question papers, they'll give you a power level. They may give you a power, or they may say that it's a power with a 0.95 power factor, so you have to apply the power factor. In each case, the power factor, you can see how it's applied here. It's applied to the voltage, it's just the voltage level. But it's P over V, basically. Describe the process for selecting the protected device. Well, again, IB, IN, IZ. So IB is the design current. We then would select the protected device, which must be equal to or greater than the design current. If it's not greater or equal to the design current, then whilst that design current is under normal considerate load, the protected device may be overloading. So it needs to be greater than, and that's as simple as that with that one. Obviously, before we go anywhere further with selecting a cable, we need to consider the rating factors. This should all be kind of triggering things from your 70th edition training. So we have to consider any methods of the installation that we have already observed, or that need to be thought that may affect the ability for the conductor for the cable to give off normal heat levels under load. So anything that's going to avoid its ability to just breathe, basically. So you're going to have to look for, are you going to install your cabling in trunking or conduits with other circuits? If you're doing a large project, you may be planning on installing 5, 6 or 7 circuits in one trunking. You've now got to obviously consider derating them due to the grouping factor there. You may have a higher ambient temperature. You may run through thermal insulation. You may have a 3036 protected device for the CF factor. etc., etc. Remember, you use the regs in this anyway. You know, the idea of this is to use the regs, not to be tested on the regs. So, become familiar. This is all in Appendix 4. This will be, if you've not done much of it before. I'll be following this video up with a little demonstration using all of this, so don't worry if you're kind of getting left behind with it. So, once we've decided what these rating factors are, CA, CI, CG, CC, we then use them with the rating protected device, and we get a tabulated current. So we don't calculate a current carrying capacity, because a current carrying capacity is determined by a cable size. What we do is we get a tabulated value of current carrying capacity, and then we select a cable which is basically the next number above that value. So once we've done that, we will then go to a table in the regs book, Appendix 4, and if we've calculated, for example, for a 2.5 installed reference method 101, if we've got an IT of 14, then we'll go here, reference method 101, 14 would be 2.5. So you should have done this. If you've not done this before, or anything we've covered so far before, then I strongly suggest you consider doing the 17th edition first. If you've done the 17th edition and you haven't done any of this, then let me know, and I'll see if I can put some content just to help you, but you should have covered this. Okay, so we've worked out IB, and then IN, and then we've done the rating factors, and we've got IT. With IT, we've selected IZ. What we then have to do is obviously verify the volt drop of our selected circuit. Okay, and that's the end point of the cable selection process, other than checking its thermal constraints. All of this I will be doing in the coming video. Okay, once we've done that, we're going to evaluate the shock risk, and we're going to evaluate the thermal risk. So we're going to make sure that the conductors that we've selected can carry the load for the duration they're going to carry them, and the protective conductor that we've selected is also suitable for the fault current that will flow. It's basically just checking. Once we've also got a cable selected, we can also verify the earth fault loop impedance as well. So once you've got a cable mapped out, we can do an awful lot of little tests just to kind of verify it's going to be working okay. Right. I've decided, because of everything we've just gone through there, I've decided that what I'm going to do before I carry on with outcome 2.3, which goes on to about explaining a bit of this, what I wanted to do was do another video, which I'm going to do probably tomorrow, which it's just a worked example of all that formula. All right. What I'm going to do though is I'll do one, but what I'm probably going to do is do an easy one that is probably going to mostly use mainly use the on-site guide for the first one, with some reference to the regulations. And what I'll do is I'll do another one that is a little bit bigger, and then I'll maybe do a third one that introduce 3-phase and power factor, just to kind of build it up a bit as we go. Okay. Again, I'm trying to keep these small, so that you can kind of go back and pick them up now and then. But the next video will be a calculation video for you to kind of follow, and then we can do some worked examples on that. Is that it? Yeah, I think that's it. One last thing I will say is the criteria of these videos is all straight out of the qualification handbook. I should have said this in the first video. So I'll put a link in the description where you can go to the City Girls website if you don't know where it is, and you can just download the handbook from there, and you can see the criteria. It's publicly available, so it's not anything that you shouldn't be able to see. Just in case you wanted to do a little bit of looking ahead, or looking at where I'm getting this information from. Because that's all I'm doing, is I'm just looking at the handbook and I'm blowing up for you guys. Alright. Yeah, see you later. Bye bye.